Alright folks, I'm going to be doing some interview prep questions related more to what I could expect in a firmware verification interview. So I think I'm just go down this list that I prompted from chat. So I think I'm going to start with a easy bit count problem. I've already done circular buffers, so I don't really see the point of revisiting that. Reversing bits, and we'll see how far we get in the hour. But I think what I'm gonna do is have this test folder get uploaded. Is there a better spot for me? That is probably better. Dirt questions and CD questions. Cool. All right. Let's start with this bit count. So let me refer back to how the test file was defined. So test bit count C. Bit count.h. Okay. Include bit count.h. Okay. So let's just have an int called bit count that is going to take in what type does this default to in C? Hang on. What type is 0x0 here when passed in? The literal goes to an int. Okay. It's just curious. Okay. So yeah, we can start by passing in our int. Cool. So all we kind of want to do here is we want a count that is set to 0. We want a while check for while the value exists, like while it's not 0, essentially. While not 0. And then we will just check. Oh, I also fixed my tabbing, finally. Anyways, while val, we do count, and equals, we would do count, no, we would do count and, count or equals val and 1, because we only want the immediate bit. And then we do val right shift equals 1. Return count. Okay, and then we want to have this in a header. So we will tab new our bit count header. And and we will just forward declare the function. And I believe we can just compile this as, let me go back. It showed how to compile it. GCC test name, your code.c, test name, and /test name. Okay. So let's see. If we do GCC bitcount.c, oh, tests, test, bitcount.c, bitcount.c dash o, bit count, then bit count.h. What is it? If not def, bit count h, def, define, bit count h. Clear the functions. And if. That's what I was forgetting. We do need int. That's a good point. This will be uint32. Okay. Okay, let's try this now. If I'm in questions directory and tests is /tests. Mm-hmm. Got it. That's what I thought it was. Cool. Alright. Assertion failed. That equals 32. Okay. Let's see what's going on. I do want to get chat out of here though. Tests, bit count. printf count %d bit count. I'm curious. If this is off by 1, I might see it, but oh, I see. I see the issue. When we and 1, it overflows. How would we do this? Hmm. Hang on 1 second. This was dumb. Okay. Oh my gosh, that was bad. Okay. Okay. That's a place to start. Okay. That. Alright. Reverse bits of a byte or integer. Okay. Mm. Okay. So we will return a uint. So we need this in here. Uint 32. Reverse. What was it? Tab new. I might draw this one out, but give me a second. Tab new tests. Reverse. Test reverse. Okay. I'm forgetting how you swap between tabs, but bits 8, bits 32. Okay. So maybe we start with the bits 8. Is that how it's named? Okay. And we're passing in. Oh, come on. What will 0 be XXXX default to? What parameter to pass in Oh, okay. uint8 square t val. So my thinking is, let's pull up paint. My thinking for this one is we'll have, whoa. We'll have this, right? Each one has a bit. We start with like a partition, or like we'll have a p equal to 7 to start, and then essentially p inverse will be at 0. So this will be here, and then this will be here. And then you would essentially just swap these two. So you would, I'm trying to think. What operation will you need here? If you have ones in both positions, you keep it as 1. So if it's a 0, and if it's a 1 being swapped. So it's a full-on replacement. And a full-on replacement okay. Let's go through it. So uint8 temp equals and int p equals 7. I guess we can start at 0 and we can do, no, it definitely makes more sense to start at 7. Okay. Well, the temp be val and 1 shifted by p. And then we'll return, what will we return from this? Because I'm trying to think, is it and equals... Oh, well, I guess... What's the test case? Because if the test case... Oh, wow. They're doing way too much. Alright. If the test case is just... returning it, then this is much easier. We can do uint8 underscore t res equals 0. I think it makes sense to initialize. So res is going to or equal at... Oh, we don't even need the temp. We can just do res or equals and then we shift this by p. Wait, but we're not shifting that by p. Because then p's gonna decrement, and we only need to decrement to the middle because we're essentially just flipping the bits. Actually, to start, let's not flip the bits, but we will need to. We're gonna have to, if we're starting at that end, we need to left shift by Um, it'll be 7 minus p, so we'll shift by z. Yeah, 7 minus p. So while p, do we do it at 0? We do it at 0. While p is greater than, oh, that is sketchy. While p is greater than -1, we'll do this. Then we will decrement p, and then return our res. Okay, let's start there. I guess we need to at least initialize the other, but this be easier in C++ where you can templatize. Just saying. Just saying. That actually might be, if I have time tomorrow, that might be something I actually do, is do these again in C++, but it defaulted to making all the tests in C, so I wasn't really going to bother. For this one, let's just return 0. I'm less sure how we would modify it in place. That seems hard. Because yeah, we have time for this. We're 20 minutes in. Okay, let me just get this test case passing really quick. Reverse bits dot h. Oh. Okay, so we want one of these to be 8. Okay. And then we want if not def reverse bits h define reverse bits h and then end def. Is that, what is it? Tab new bit count dot h. Oh, it's just end of. That's gonna be annoying. Tests, test, reverse. And this needs to be questions. Oh, interesting. Okay. First of all, let's get a bin to deck. 13. All right. So let's look at our reverse bits. Nope, not the empty one. This one. That's not what I wanted. I wanted to look at here. So the first one passed. Okay. can just copy all of this. $128. That's weird. Alright, let me think about this. What are we doing here? Also, 128 is our max number of digits. Okay. 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 So we have our test case now. We have let's just delete all of that. Can you really not delete any other way? That's crazy. All right. So 1 1 0 1 1 0 0 0 0. Okay. Let's look. So we start with res equals 0, or equals val and 1 shifted by 7. So 1 is here, shifted by 1, shifted by 2, shifted by 3, shifted by 4, shifted by 5, shifted by 6, shifted by 7. So that should then be left shifted by nothing. Oh. We need to right shift this. Hey, what is my thinking of what's happening here is val and hang on. Result of val and 1 shifted by 4, assuming a 1 is there. It'll be shifted by that much. Okay. Wait. Bit 4 is 1. So yeah, we should not be shifting. What was I doing? Okay, that will be in place. So we want to 1 shifted by P. So here we want to right shift by P, actually. Right? We right shift by P on the first. And then this will decrement to 0. And then that will be our last, yes. Yes, this is right. What now? What about... Why did I do it this way? Dude. Res equals 1. Wait, of course it does. Okay, let me think about this. Okay, I think for the sake of everything holy, we start at 0. Then we do while p is less than 8. Okay, so val and 1 shifted by p, then right shifted by p. What needs to change here? So obviously we're bit extracting like so. That's our bit extraction. When we start at 0, we need to shift by 7. So we want to do, and then for 1, we want to, wait. Hang on. Let me think about this. At 1, we want to shift by 7. Here, we don't want to shift by, 6. We want to shift by 1, 2, 3, 4, 5. And then here, we want to shift by 1, 2, 3. So it goes 7, 5, 3. That was terrible. Okay, and then we're here. We're at bit 3. We want it to shift by 1. We want it to shift by 1. Then we're here. We want it to shift right by 1. Let's call it -1. Then we get here. We want to shift by 1, 2, 3. -3. Then we get here. And we want to shift by 1, 2, 3, 4, 5. -5. And -7. Okay. So we essentially need to okay. When we're at 0, we will have an int called shift amount equals okay. We're starting at 0 and our shift is 7. When we get to okay, hang on. We know there's a 7. We know there's a 7. Or 8 minus 1. For 0. And then the next will be 5. So what is wrong with this? Let's look. So at bit 1, it'll be 5. At bit 2, it'll be 3. At bit 4, it'll be 1. At bit 5, it'll be -1. Hang on. At bit 0, it'll be 7. At bit 1, it'll be 5. At bit 2, it'll be 3. At bit 4, it'll be 1. At bit 5, it'll be -1. Why is this not clicking for me? We do 1. So this is 0. This is 1. This is 2. This is 3. Because that's bit... I was counting wrong. 4, 5, 6, 7. Alright. And then we will have a ternary operator here. So this part is correct. I guess we'll do this in a unit. Unit 8 temp equals val and 1 shifted by p. Okay. Now we will do res of sham. Oh, I guess we didn't. It's cleaner. If shift amount is less than 0, what we doing? We are. If shift amount is less than 0, we are shifting right. So temp shift right. Is it by? Yes, it is by shift amount times -1. And if that's not true, then we just do temp left shift amount. Okay. I feel pretty good about this. Okay, good. So here we just expand the logic a little bit more. I think I actually just might copy all of this. Make sure I remember to change all the typings. This will be instead 32. This will be everything stays the same. It's just bigger values. I think we're good. Okay. There's another. Let's add everything in here. Git commit -m. 2 probs. I got 2 problems and you are 1. Alright, we have 20 minutes. Let me go grab my water. Reset, and I'll be right back. Next question. I forget what the next question is. Alright. Next question is a CRC. Okay, cool. Alright, BRB. Where is my video capture? There it is. Okay, I'm back. Let's crank out another, shall we? So I'm thinking, first thing, let's change that test to reference to the right spot. Okay, and what's getting passed here? A char, which can get evaluated just to an int, but Zor checksum giving the size as well. Oh, that's nice. Okay. This should be really easy. It should, so this one, char is just going to uint 8. I don't know why they wrote the test like that, but it's the same, essentially. Since we have a char array, all we're gonna do is keep a result that is going to, through this process, Zor equals with the next item in the array. And I think it should be that simple. So, let's get started. Ooh, did they want an int passing? Whatever. We'll do a uint. I forget what size they were giving me. Let's do 8. They're passing in char array. Yeah, we can do 8. Let's call it whatever it got called in the test file. Zor checksum. Okay. Spoilers. We will pass in a char pointer. Array. And int size. We will have a uint 8 result that starts as 0 for int I equals 0, I less than size, I increment, res Zor equals with the array at I. Return res. Okay, I really think that's all that's going to be needed, but if not defined, checksum h define, define checksum h. And if. All right. I think we are done here. What's the compile pattern? We'll test checksum. We will do a checksum, and we'll compile the same spot. Hang on 1 second. Oh, I didn't define. Silly me. Include std int.h. It's also not in the header. Include std int.h. Okay. Wow! That might be the easiest thing ever. Okay. Whoops. Git add, git commit, -m, checksum problem. I do think for something like that, writing the tests is kind of the important thing as well. But um, my interview's in a week, and for the sake of time, I would rather just have those tests already implemented. This is a medium. I guess if you see the test, it changes your outcome to some degree. Um, Honestly, three's a palatable amount. I know they were insanely easy, but I think that's a good place to start for now. Um, yeah, I'm realizing like I'm filming the C++ studying just to keep myself accountable, but I think with these, I'll keep them more palatable in the less than hour range, and try to explain a little bit better. I think Paint goes a long way as far as drawing these out. But yeah, I yeah, thanks for listening alongside. Um, and hopefully, like it goes without saying, pause at any point and do these problems on your own. But um, yeah, just learn by doing. That's what I'm trying to do. Anyways, see ya.